Alright, so one thing that's definitely different about this question is it doesn't just say solve, it says find the solutions between 0 and 2 pi. So in the end, our answer should not have things like plus 2 pi in it, because that would give us outside of this range. That's good if you want to know the coterminal angles as well, but the directions are saying just find between 0 and 2 pi. So one revolution. Okay, so I look at this and it looks like a quadratic. I've got something squared. So I know when I want to solve a quadratic, I like to move everything over to one side, set equal to 0. So hopefully you did that. It's like I've got 2x squareds and a minus x and a minus 2. Except one thing that complicates this question is these are sines and these are cosines. So you can't just factor this. Not into two binomials, at least. Not anything I can think of. So you're not ready to factor. Instead, you've got to use your trig identities, and you've either got to change these into sines, and I can't change tangent into sines without putting in some other trig functions. But right here, I can rewrite sines in terms of cosines. So our first Pythagorean identity says that sine squared plus cosine squared equals 1. So sine squared would be equal to 1 minus cosine squared. Okay, and then that's really the step that separates this from the last question. So if you've been doing fine with the previous questions, this is where you need to slow down and understand. You need to see, even though I'm still several steps from being finished here, why this is better so that you get an idea of why I wanted to make this substitution. All of these are now cosines, so after some cleaning up, I will be able to factor this because they're all the same trig type. These had multiple different types of trig types, and they were just not going to work well together. So distribute your 2. And I'm going to try to put it back in standard position. So highest exponent first, next highest exponent. So 2 minus 2 would be 0, so those just go away. Okay, and then I am going to still factor. It just doesn't look like it's a trinomial. I've just got 1, 2 terms. But I can still do that with a GCF. They both have a 2 or a negative. They both have a cosine x. And negative cosine x times 2 cosine x gives me this. And negative cosine x times 1 gives me negative cosine x. So I factored there, I factored GCF. Because now, this times this equals 0, so that could be where this equals 0. So where cosine x equals 0. And where this equals 0. Subtract 1, divide the 2. So now I can go and think about the unit circle here. Cosine is 0, those two locations, and it is negative 1/2 at these locations. And so again, don't say pi over 2 plus 2 pi n, 2 pi over 3 plus 2 pi n, no plus 2 pi n's, because the directions say just between 0 and 2 pi. So this is pi over 2. This is 2 pi over 3. This is 4 pi over 3. And this is 3 pi over 2. Those 4 values are solutions to our original equation.